All right, so you're trying carbonate on your own. This is your learning check. And so carbonate, first we need to know that's CO3 minus 2 because it's a polyatomic ion with a -2 charge. Carbon and oxygen are both nonmetals, so I'm still doing covalent. So first rule for covalent bonds, figure out who's in the center. Carbon 4 gaps, oxygen 2. Carbon least electronegative. Carbon gives symmetry. Carbon for the win for the central. Okay. And I'm going to spread those oxygens out. Now that I've done Vesper, I have an idea that they're all going to push to those farthest corners. And I am going to count how many electrons should I have. I have 4 valence electrons for each carbon, plus 6 valence electrons for each oxygen, plus 2 electrons because of that added charge. Electrons are negative, giving me 24 electrons. So now I'm going to build my octets. Okay. So 2, 4, 6, 7, 8. And now I'm going to count 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26. So that structure is not correct. I have 2 extra electrons. So I'm going to take off my 2 lone pairs and I'm going to redraw again. I'm going to recreate the wheel. But in this case, I'm going to add 1 double bond and then go ahead and do my octets. 2, 4, 6, 8, 2, 4, 6, 8, 2, 4, 6, 8. Okay, and now I'm going to count again. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. I hit my 24, so I'm going to stop here, bracket and charge, and then go back and check where are my charges at. I need to prove the -2. If you didn't prove the -2 down here, you're not going to get credit for the Lewis dot structure. You do have to show how he's a -2. 1, 2, 3, 4, 5, 6. He's supposed to have 6. He has 1 extra. It's a negative. You don't have to show the math if you don't want to show the math, but do make sure you show at each element what charge it is. 1, 2, 3, 4, 5, 6, 7. So he's a negative. 1, 2, 3, 4, 5, 6. He's perfectly balanced. He has 6 valence electrons, and he's showing 6 in this drawing. Okay, remember it's valence minus the actual shown electrons is equal to that charge. Okay. And center, 2, 4, 6, 8. Oh, sorry, 1, 2, 3, 4. He's also a 0 charge. He's supposed to have 4 valence electrons, and he has 4 sides of the bar. And -2 equals -2. So I have -1 2 times equals -2. So I did prove that charge there. Now, if you happen to do this and you put the double bond here or here, it does not matter because remember, we could just rotate around that carbonate. As long as you're showing a double bond somewhere and 2 single bonds elsewhere, then you are good. And then in next year in chemistry, we'll learn more about what actually happens with carbonate.